Okay, looking at a little bit more vocabulary for our graphs. The degree of a vertex is the number of edges that happen to meet at that vertex. So every vertex will have a degree of at least 0. And so you can see some of those here. So this is the first one is degree 0 because there are no edges going into it. The second one is degree 1 because there's one edge going into it. Degree 2, 2 edges, etc. And you can have as many degrees as you want for any vertex. There are no limits other than it has to be at least 0. So perhaps not surprisingly, a vertex is said to be an even vertex if the degree of the vertex is even, and that vertex is an odd vertex if the degree of the vertex is odd. Whenever you have two vertices that are joined together by one or more edges, those are called adjacent vertices. And that's the end of the vocab part, but just a couple questions to see how we're doing here. If you have a vertex of degree 0, is that an even vertex, an odd vertex, or neither one? Well, 0 is an even number, and so that is going to be an even vertex. And then a degree for a vertex with a loop. So even though that looks like one big edge, there actually are two places where an edge goes into a vertex. There's like an enter and an exit, if you will, or two entry points. And so that vertex actually has degree 2. So let's do a little practice with this. Looking at vertex A over here, the degree of this vertex is going to be 2 because there are 2 edges leading into that vertex. That is clearly even. And then adjacent vertices. So what vertices do the edges lead you to? They lead you to vertices C and to D. Okay, moving on to vertex B. Vertex B also has degree 2, which is even, and vertex B is adjacent to vertex F and to C. Right, then looking at vertex C, the degree of the vertex is 1, 2, 3, 4, 5, and 6. Remember, you got to count every entrance and or exit, depending on how you want to look at them, out of that vertex. So there are 6 degrees there. That is even. And then when you look at all of the vertices that is adjacent to, it's going to get a little cluttered here. When you look at all the ones that you're adjacent to B, you're adjacent to F, and to E, sorry, not E, D, I'm looking at the wrong vertex there. You're adjacent to B, to F, and to D. Okay, and then you don't really think of C being connected to itself, so that even though there's a loop there, we don't list it as being adjacent to itself. Okay. All right, continue on working on the degree, even or odd, and adjacent vertices for D, E, and F. Pause the video, come back when you're done. All right, again, so take a look and see how you did. You should end up with a couple odd vertices, first ones we saw on that graph, as well as an even, and then your list of adjacent vertices as well. How you list them doesn't matter. As long as you have the same ones listed, that is what is important. Right, and then the last example on this page, now I'm going to have you draw a graph that has the characteristics given. Okay, so we need one vertex with degree 1, 2 vertices with degree 2, 3 vertices with degree 3, and 2 vertices with degree 4. So before I have you pause the video and try this out, I want you to pay attention to these numbers here. That tells you the total number of vertices that have to be present in your graph. So if you add up 1, 2, 3, and 2, you will know how many total vertices have to be in your graph. Then you need to get those degrees to work out. So pause the video, Draw your graph the best you can do. There's lots of right answers to this question, and then come back and see if your graph works out. Okay, so I'm going to begin by drawing in those vertices. We need one vertex plus two more vertices plus three more vertices plus two more vertices. There's nothing special about the circular arrangement I made. I just find it sometimes easier to work with. So that tells you, again, by adding up all of these numbers here, that we need a total of 8 vertices. And now we need to take care of the degrees. Your strategy for the degrees can vary. I'm going to actually start with my vertex of degree 1. I'm going to kind of get that one out of the way so that I know not to use it again. I'm just going to label that a 1. This is kind of my scratch work, if you will. And I'm going to connect it over here. And so now I know I've got that part out of the way, and I shouldn't touch that vertex that I've got labeled as a degree 1. I tend then, once I take care of the ones of lowest degree, I tend to kind of bounce to the ones then of highest degree. And again, there's not really a right or a wrong way to do this. This is just the way my mind processes things. And so I'm going to start with this vertex that I connected to my vertex of degree 1, this little guy right here. I'm going to make this a degree 4. So I'm going to connect it up to 3 more vertices. So now I've got degree 4 there, and I can call it good. I'm going to go to this next vertex down. I'm going to make that a degree 4 as well. And notice I do not want to connect it up that direction, because if I do, that will turn that vertex that I just left into a degree 5 vertex, which I do not want. So I'm going to go to 4 other vertices. I'm going to go 1, 2, 3, 4. And now I've got my vertices of degree 4. From there, again, it's kind of a game of hit and miss. Right now I have a lot of vertices of degree 3, or degree 2, sorry. I've got these over here that are degree 2, and I've got a 1 and a 0. Those are definitely going to be problems. I don't want that to happen. I want 3 vertices to have degree 3. So what I'm going to do is I'm going to start with the 0 because I know I need to increase his degree. I'm going to connect that one over here to the 2. That's going to turn that degree 2 into a degree 3. Right now this 0 is then at a 1. And so looking at my goal here, I do have 2 vertices with degree 2. I have my vertex with degree 1. I've got my vertices with degree 4. So the question is, I need 3 vertices with degree 3. How can I make that happen? Well, I think what I'm going to probably do here is turn the vertices of degree 2 that I thought maybe were set. I'm going to change my mind. I'm going to make those be the vertices of degree 3. Each one of those is a degree 3. Oops, sorry, draw that down there. And then if I connect up these last 2, then those are now vertices of degree 2. And so I do, cleaning that up a little bit, cleaning up all my scratch work, I've got my 2 vertices of degree 4 over there. In these 2 spots, my vertices of degree 4 right there and there. I've got 2 vertices with degree 2. I have 1, 2, 3 vertices with degree 3, and then my vertex of degree 1. And again, your graph might look very different than that. It's all about trial and error.